In this video, I'm going to talk about how to determine the number of solar panels that will be required for a particular inverter system, especially hybrid inverter system. Please welcome to my JK Multimedia Solutions channel, and please do subscribe to my channel if you have not done so, as you follow me in this video. Thank you. What we are saying here is that we have the three-phase hybrid inverter here with MPPT charge controller. Alright, and we have the solar panels here where we have the sun shining on the solar panels. So we have the generator and then the mains. So we have the changeover switch here to select the mains or the generator, and we have the battery bank here. So here we have the inverter AC load, that's alternating current load. Now what we are saying is, if there is mains supply, alright, the mains voltage will charge the battery, alright, and at the same time it will bypass the inverter function and supply AC voltage directly to the AC load. But in a situation where the mains voltage is not available, then and the generator also is not being used, then what will happen here is that the solar panel, provided that is during the day, the solar panel will have to power the AC load through the inverter action, and at the same time or simultaneously it will charge the battery bank as well. So there are two things: the solar panel will provide power to the AC load and at the same time charge the battery bank. Now continue to follow me as I use an example to illustrate the concept that I'm talking about here. Now the illustration. Examples. A. Calculate the number of solar panels required to charge a 48 volts 1200 ampere hour battery bank fully, that is 100%, given that sunshine time is equal to 7 hours. Assume that the lithium battery bank had been fully discharged. That's the A part. Then B part, determine the number of solar panels required to charge a 12 volts 200 ampere hour battery bank fully, that is 100%. Sunshine time is equal to 7 hours as well, and also assume that the lithium battery bank had been fully discharged. In both cases, it is clear that the batteries are lithium batteries. All right. Now, solutions to the questions. The A part, there are two methods for going about the solutions. Alright, the first method is this. Now we have 48 volts 1200 ampere hour battery bank. So the one of the easiest ways is to convert the ampere hour to watt hour, and you do that by multiplying the ampere hour by the voltage, which is what here to give us this. And if you are converting the watt hour to ampere hour, also you divide by the voltage. So in this case, you are multiplying the ampere hour by the voltage to get the watt hour, and then we move on. So assuming when one wants to use 500 watts solar panel, it's left to the designer if you want to use 500 or another rating of a solar panel, but in this situation I'm using 500 watt. It could be 250 watt or whatever. So making use of 500 watt solar panels, so the number, since we have been given that the sunshine time is 7 hours, all right, so assume 500 watt solar panels are to be used, then 500 watts in 7 hours will give 500 watts times 7 hours, and this is the value. So we can now calculate the number of 500 watt solar panels required by dividing this by what we are getting here, and the answer is 16. Also, if the inverter load is 10 kilowatts, or call it 10 kVA, then the number of 500 watt solar panel, right, to power the inverter load will be equal to 10,000 watt divided by 500 watt. That will give us 20. So assume that the hybrid inverter itself is of 10 kVA rating. And the second method, so similarly, we convert 1200 ampere hour to watt hour, and this is what we are getting. So 500, making use of 500 watt solar panels as well. So that will give us total amount of power required for full charge is equal to this divided by 7 hours, since we know that the sunshine time is 7 hours. The hour will cancel hour, and we have 57600 watts. So, and this is the result. So we can now calculate the number of 500 watt solar panel there, and that will give us 16. So, and then just likewise, just like we did in A part, the number of solar panels for the inverter load itself. If the inverter load is 10,000 kilowatt or 10,000, if it is 10 kilowatts or 10,000 watts, or we can call it 10 kVA, and that will give us 20. So the total number of solar panels for charging the battery and simultaneously supplying power to the inverter load will be 16 plus 20, giving us 36. Moving on to question B. Method 1. To charge 12 volt 200 ampere hour lithium battery bank fully using 500 watt solar panels in 7 hours sunshine time. So then 500 watts solar panel will give this, multiplied by the number of hours will give us this, and then to change it to watt hour we multiply this by 12 volts and it will give us this. So, and the answer will be approximately 1. But if we use 400 watt solar panel, it will still be okay. Assuming the inverter load is 1 kVA, so we will require we will need the 2 number 500 watts solar panel for that. And if it is 400 watt also, I think that one could be, I think we will need more of that, because that 2 will give us 800, that will be 3. But in this situation we are using 500 watts. So we have, for the battery charging, we have 1, and then for the inverter load we have 2, and that will give us 3. Finally, the second method of B part. So to charge 12 volts 200 ampere hour lithium battery bank fully using 500 watt solar panels in 7 sunshine time, 7 hours sunshine time. So this one, converting it from ampere hour to watt hour will give us this. Alright, and in 7 hours, if we divide it, use 7 to divide this, it will give us this. Assuming we want to charge it quickly, so this one will maybe if the sunshine time is 1 hour, instead of 7, this would have been 1 hour, and the number of solar panels will have been more. If it is 2 hours, it will have the sunshine time. If it's 2 hours, this one will have been 2. Alright, so now that it is 7, in 7 hours it will give us this. So the number of 500 watt solar panel required be 343 divided by 500, which is approximately 1, and 400 watt will also do the work. So, and then if the inverter load is 1 kVA, the total number of 500 watt solar panel required will be 3. And that is the end of the presentation. And please do subscribe to my JK Multimedia Solutions channel. I expect more exciting videos. Thanks for watching.